Hello, quick video on regression line calculations from total stats as used in the Mei S2 syllabus, and I'm going to use the Jan 2010 question 1 as an example. So as ever, first thing we do is I read the question. A pilot records the takeoff distances for his light aircraft on runways at various altitudes. The data shown in the table is below, there we are, and A is meters is the altitude of the runway and T is the takeoff distance. Okay, also see below some summary statistics, there they are there. First thing, so it's question 1, part 1. Draw a scatter diagram to illustrate the data. Well, I've put the figures into calculator here and sort of preempted part 2 because the A values are in list 1 and the T values are in list 2, and if I graph them I get basically a pretty straight line there, don't I? In terms of what you've got to do if you're drawing it is make sure you accurately put your A and T values on, make sure that you've labelled your axes. So the x-axis is A, which is altitude in meters, and the y-axis is T, which is takeoff distance in meters. Okay, let's have a look at the next part then. 2. State which of the two variables A and T is the independent and which is the dependent. Right, and explain your answer. Well, what's this guy doing here? Well, he's trying to work out that at different altitudes what the takeoff distance is, and therefore his table's set up that way, isn't it, with the altitude being 0, 300, 600, 900. So he's fixing that. So that's going to be our independent variable A, and for each value of A he's going to try and work out what these takeoff distances. So that's the dependent variable. That's what he's doing. So A is the independent, T is the dependent, and the reason for that is he's trying to predict what his takeoff distance is at a particular altitude. Okay, part 3. Calculate the equation of the regression line of T on A. Okay, so the first thing we're doing here is this part 3. We're doing the regression line now, aren't we? Okay, and there's 2 things we need, one of which is the data formula book, and that's below here for the formulae, and the other one is which is x, which is y. Well, x is our independent variable, so in this case that's going to be A because that's our altitude, that's what's driving it, and y is going to be our dependent variable. In this case it's going to be T. Okay, and what we've got here is our formula for regression. So y minus y bar is going to equal b times, in brackets, x minus x bar, and they've given us here a formula for finding b, which is this expression here. Okay, so what we're going to do first, well, let's find out what x bar is. So x bar is a bar, which is the total was 6300 divided by 7, wasn't it? So that gave us our average altitude as 900 meters. And our y bar is our t bar, which we got was 5987, which divided by 7 gave us 855. So our average takeoff distance is 855 meters. Our next part of this is to work out what b is using the formula. So if I just sub in so we can see it, so converting our x and y into a and t, so that's our sum of a and t over n minus our a bar t bar over the sum of a squared there over n minus a bar squared, isn't it? So using our figures that we had earlier, we can see that that's 6037 800 over 7 minus 900 times 855 over what we've got here, we've got 8,190 over 7 minus 900 squared, and if we put that in our calculator that figure is going to come out as 0.2577. Okay, our next step is to sub that into the formula and work out what our constant is. So t minus t bar, and t bar here was 855, must equal 0.2577 times a minus a bar, which is 900 there, isn't it? So reorganizing that, we're going to get t equals 0.2577 of a plus, bringing the 855 over, take away this part 2577 times 900 for this side. Okay, so the result is going to be here that t equals 0.2577a plus 623. So that's our regression equation. Okay, what we're going to do next, see what it asks us to do next. Next, I think it's asked us to do some predictions. Use the equation of the regression line to calculate estimates of takeoff distances at altitudes 800 meters and 2,500 and comment on the reliability of these estimates. Okay, so let's have a look. So we've got our regression line and we're using 800 and 2500, aren't we? Let's just get rid of this line here, excuse me. Let's get rid of it, excuse me, and delete that. Okay, so it's now asked us, let's do this in green. This is number 4 for predictions. Predict takeoff distance. Okay, A. It is when A equals 800, and we're just going to put the value in here. So T equals 0.2577 times 800 plus 623 equals 829 meters. Now A of 800 is within the range of our data. Let's have a get range of data. Let's go back to the top just to convince ourselves of that. There it is. The data we've got is between 0 and 1800. Yeah. So it's within the range of our data, and therefore we would call that. So that's interpolation, and that is therefore, because we're within the range, it's therefore safe and reliable. Okay. Okay. Second one they want us to find was when A equals 2500. So again, putting the figures in, we get 0.2577 times 800 plus 623, and that's going to be equal to 1,267 meters. However, but 2,500 is outside the range of data. Therefore, it's extrapolation, and it's therefore unreliable. That's what you need to write. People on Space Shuttle can tell you about that, because they did it, extrapolated on temperature, and it didn't work out for them and they crashed. Okay, let's see what the next part, the final part of the question is here then. Calculate the residual value for data point A equals 1200, T equals 923, and comment on its sign. Okay. So let's do that. Let's calculate residual. Okay, calculate residual. A equals 1200 and T actual was 923 meters, wasn't it? Okay, So what are we going to do? We're going to find our prediction first. Our prediction is t equals 0.2577 times 1200 plus 623. There we go, plus 623 gives us a value of 932 meters. Now the residual is the actual minus prediction, and in this case therefore we're going to have 923 was the actual, the observed. We're going to take away 932, so we've got a minus 9 meters here. It's negative, so what does that tell us? It tells us that the actual takeoff distance is less than the prediction. Less than prediction. Here we go. Okay, that's answered the question. As ever, here's my little summary at the end. For regression totals, well, the formulae are on page 6. For getting the regression, it's overall the regression equation, and also for the sums that you're looking for. If they ask you to predict using the regression line, then if it's within the range, it's called interpolation, and that's safe and reliable. If you go outside and you start extrapolating, that's unsafe and unreliable, because you don't know where the data's gone beyond the range of your known. Residuals, that's your actual minus your prediction, and it shows the error in your predictions, and you just comment in context. There we go. I hope that's of use.